So we're looking at three resonance forms, and we're going to try and show how we can use curved arrows to convert from one structure to the next, and then we'll see if we can rank each resonance form. So comparing the first and the second resonance form, I see that I've broken the pi bond and moved the electrons up onto this top oxygen. So I could do that with just one curved arrow, and the arrow starts with the pi bond and moves up to the oxygen. So I can see there's three lone pairs on the oxygen now. And to go from the second form to the third form, I can see that I need to move one of these lone pairs on the bottom oxygen to be a pi bond, and so my arrow is going to start at the lone pair and move to be a pi bond to the bottom oxygen. The problem also asks how I could convert from the very first structure to the third structure, and I could do that by considering that I have an allylic lone pair. And every time there's an allylic lone pair next to a pi bond, I can move the pi bond, I could move the lone pair to become a pi bond, and then the pi bond becomes a lone pair, and that would convert directly to the third resonance form. Okay, now if I want to rank the three resonance forms, the most important thing to look for is filled octets, and I can see if there's any missing octets, and I would see that this middle structure is missing an octet on the carbon, and that makes that the poorest contributor, the least important contributor, and so this is the worst resonance form. And the other two all have filled octets, and they both have a charge on negative charge on the oxygen, so that's good. So that is the best resonance form, and they're equal. So these two are the best resonance forms, and that would be the #1 ranking. And so that's what the actual structure of this compound looks most like, is a hybrid of those two, while this middle form contributes just a little bit, showing that that carbon has a slight partial positive character.